Hello everyone, welcome to MediHope-Math-AI channel. In this channel, we will discuss about math, different courses of math like Calculus 1, 2, 3, Algebra, Pre-Calc, and so on. So stay with me. Today, I'll show you how do we define limits and how do you evaluate or find the limit of a function at a given point. So first, why do we need or how to find the limits? Okay. So when we say limit, the concept of a limit is one of the central idea in calculus. Before studying like derivatives and integrals, we must understand how a function behaves as the input approaching a particular value. So normally we use the standard notation of limit as this one. Then we can read as the limit of f of x as x approaches to L. So the word approaching is essential. Means as x moves closer and closer to A, but does not need to be exactly equal to A. What matters is the behavior of the function value of f of x near x is equal to A. So if the output of a function gets closer and closer to the same number L as x approaches to A, then the limit exists and its value equals L. So it's very important to note that the limit centers the nearby behavior of a function. Therefore, the function may have different value at x equal to A, or a function may be undefined at x equal to A, yet the limit may still exist. So how do or when do we say that the limit is exist? First, let's see the one-side notation. The first one, this one, is known as the left-hand limit. Means that x approaching A through the values less than A. And the second one is the right-hand limit, meaning that x approaches A through the value greater than A. A two-sided limit exists. Only when the left side limit exists, and also if the right side limit exists, and both have the same or equal limit. So we can say that the limit of a function f of x as x approaches to A equals L, or we can say the limit exists. Now I'll show you some techniques how to find or how to evaluate the limit. Stay with me. Don't forget to subscribe and write comments. So first, let's see the direct substitution. When do we use this method, right? So the direct substitution should be the first techniques used when evaluating a limit. If the function is continuous at x equal to A, continuous means when we draw the graph of the function, if our pen is not lifted, right? So the limit of the function f of x as x approaches to A equals f of A. This is known as the direct substitution method of limit. Let's see some examples of how do we use this direct substitution. Example 1, let's find limit of 3x plus 1 as x approaches to 4. Our f of x is 3x plus 1, and the value of a here is 4. Now equals direct substitution minus 3 of 4 plus 1. 3 times 4, we got 12 plus 1 equals 13. So we have the value. So when we replace x with a, produce a real number immediately, then the limit is found with no further algebraic work. You see, when we replace x by 4, we got 13. So that means the limit of 3x plus 1 when x approaches to 4 is 13. Let's see example 2. Limit of x cubed plus 5x as x approaches to 2. Again, let's use direct substitution. 2 cubed plus 5 times 2. So 2 cubed 8 plus 10 equals 18. We got a real number, therefore the limit of x cubed plus 5x as x approaches to 2 is 18. Now this is for you. Limit of square root of x plus 3 as x approaches to 9. Write the value of this one in the comment section. Okay. Now let me show you the second techniques of limit, which is known as factoring. When do we use this factoring? Factoring is essentially used when direct substitution is given the indeterminate form of 0 over 0. When you apply direct substitution, if the result gives you 0 over 0, then we have to apply factoring. The standard for this is what? Factor the numerator or denominator. Then, and or, right? Then cancel common factors. Then substitute again. Okay? Substitute again means, okay, let me show you this one using examples. 1. Limit of x squared minus 9 over x minus 3. No, I don't need this. For that, limit of x squared minus 9 over x minus 3 as x approaches to 3. So let's apply direct substitution. The first technique should be direct substitution. Therefore, 3 squared minus 9 over 3 minus 3. 3 squared, we got 9 minus 9 over 3 minus 3 gives us 0 over 0 indeterminate. So let's factor what? The denominator, which is x squared minus 9. Therefore, we have to factor, right? Factor x squared minus 9, which is equal to x minus 3 and x plus 3. Now let's find, then we will have x squared minus 9, x minus 3 equals x minus 3 and x plus 3 over x minus 3. We have x minus 3 with x minus 3. So this gives us x plus 3. Now, limit of x squared minus 9 over x minus 3 as x approaches to 3, same as limit of x plus 3 as x approaches to 3. Now let's apply direct substitution. Then 3 plus 3, which equal to 6. We got real number. Okay. Therefore, limit of x squared minus 9 as x minus 3, x approaches to 3 equals 6. This is the second technique of the limit, okay, using factoring. Now, let me give you exercise. Now find limit of square root of x minus 2 limit of 25 minus x squared over x plus 5 as x approaches to negative 5. What will be the answer? Okay, write your answer on the comments. The third techniques of limit, okay, which is known as common denominator. When do we use this common denominator? Again, this method is used when the expression contains fractions that are added or subtracted. Such limits often produce 0 over 0 until fractions are combined into a single fraction, a rational expression. Let's say we have to find a common denominator and then combine the terms into one fraction and then simplify, then finally evaluate the limit. Okay, so example for these techniques of a limit. Let's find the limit of 1 over x minus 1 over 2 over x minus 2 as x approaches to 2. Okay, first combine the denominator. Okay. So let's do our solution this side. Let's combine, right? Combine the denominator or numerator. In this case, we will combine the numerator, which is 1 over x minus 1 over 2. So this gives us 2 minus x over 2x. So what we have, 1 over x minus 1 over 2 over x minus 2 equals 2 minus x over 2x over x minus 2. By the way, 2 minus x is the same as negative of x minus 2. So we get 2 minus x over 2x comes what? X minus 2. Because this is the same as 2 minus x over 2x x minus 2 equals negative of x minus 2 over 2x x minus 2. Now we have common factor, which is x minus 2 with x minus 2. This gives us negative 1 over 2x. Next, let's find the limit. So limit of negative 1 over 2x as x approach to 2. Now direct substitution, minus 1 over 2 times 2, which is negative 1 over 4. So the limit of the limit of 1 over x minus 1 over 2 over x minus 2 is negative 1 over 4, because from here. Okay? So what's next? I think let me give you one exercise, okay? Just to practice to evaluate the limit, okay? Evaluate the limit of 1 over x plus 1 minus 1 over 2 over x minus 1 as x goes to 1. Write your answers on the comment section, okay? Now let me proceed to the fourth techniques of limit, okay? Fourth limit. Expand, or if we have open up parentheses, or we can, how do we expand? Okay, expanding is very helpful when expressing expressions we have, like, let's say, if you got x plus a, this is a, sorry, let me write it again. There's a x plus a squared, or we can write this one as well, x squared plus 2ax plus a squared. Or if we have expression like, by the way, this is the same as x plus a times x plus a. Okay, they are the same. So expand the expression algebraically means we can write x squared plus a the whole square as x plus a times x plus a. And then we will simplify, and then we can cancel common terms if possible, right? Then evaluate the resulting function, or resulting function. So let's say example, okay? Example. Evaluate limit, let me use red. Limit of x plus 2 the whole square minus 4 over x as x approach to 0. Always, when you find the limit of a function, just first try using direct substitution, okay? If you use direct substitution, okay, let's use direct substitution for this one. Then we have what? 0 plus 2 squared minus 4 over 0. Then we have 4 minus 4 over 0, which is 0 over 0. Indeterminate type of 0 over 0. So we have to change our techniques from direct substitution to another one, which is expand. How do we expand? Okay. How do we expand? Expand the numerator, okay? Expand this one, x plus 2 the whole square, which is the same as So it's the same as 2 squared minus 4. So we have x squared plus 2 times 2. We'll have 4, so 4x plus 2 squared, we got 4 minus 4. Now we have 4, right? This is 4 minus 4, which is 0. So we got x squared plus 4x. Now again, x plus 2 squared minus 4 over x, which is the same as x squared plus 4x over x. So the common factor from the denominator is x into x plus 4 over x. Cancel common factor, then we got x plus 4. Now, the limit of x plus 2 squared minus 4 over x as x approaches to 0 is the same as limit of x plus 4 as x approaches to 0. Direct substitution, so 0 plus 4, we got 4. This is the limit of x plus 2 the whole square minus 4 over x. Okay. Now exercise for you. 2. Evaluate. Okay. Limit of x plus 1, x plus 3, minus 8 over x minus 1 as x approaches to 1. Again, please write your answer in the comment section, then I'll check for you, okay? That's good. What's our fifth? For fifths, we have a square root in the numerator or denominator, which is known as normally rationalizing, okay? When do we use this one? Rationalizing is just used when radicals produce an indeterminate form, such as 0 over 0. They give us as 0 over 0, then we have to use rationalization. So we have to at least recall our a minus b into a plus b equals always a square minus b square. So to rationalize, we have to multiply denominator or denominator by the conjugate expression. Okay, what's conjugate or how do we apply? Let me show using examples again. 1. Okay, find what? Limit of square root of x minus 2 over x minus 4 as x goes to 4. Okay, as I told you, if we apply direct substitution, let's apply direct substitution, which is square root of 4 minus 2 over 4 minus 4. Square root of 4, we got 2 minus 2 over 4 minus 4, which is 0 over 0. So we have to multiply the conjugate, right? Okay. We have square root of x minus 2 over x minus 4 multiplied by the conjugate, that conjugate of square root of x plus 2 over square root of x plus 2. This gives us x minus 4 over x minus 4 times square root of x plus 2. So since we have x minus 4, x minus 4, this becomes 1 over square root of x plus 2. Therefore, substitute x equal to 4. Just direct substitution, right? Limit of 1 over square root of x plus 2 as x tends to 4. Using direct substitution, 1 over square root of 4 plus 2 equals 1 over 2 plus 2, which gives us 1 over 4. So this is the limit of square root of x minus 2 over x minus 4, and it exists. Okay, exercise. Just evaluate. Evaluate limit of square root of x plus 9 minus 3 over x as x goes to 0. What will be your answer? Use rationalization, okay? Okay, number 6, or the 6 techniques of limit is what is special trigonometric limits. Okay, so limit of sine x over x as x approach to 0 is always 1, and limit of tangent x tan of x over x as x approach to 0 is also 1, and limit of 1 minus cos of x over x as x approach to 0 is 0. So we have to at least understand this one. How do we prove, or how do we find the limit of let's say sine of x over x is approaching, when x approaches to 0 is 1. For now, because we are discussing about the limit, just we have to remember the limit of the special trigonometric limits. Using derivative, we can prove that limit of sine x over x as x approaches to 0 is 1, and similar for the other two. Okay. Okay, so this identities are valid only when the angles are measured in radian. Okay, it has to be in radian. Now let's evaluate the limit. Limit of sine of 5x over x as x approaches to 0. So how do we find the limit of this function? First, we have to rewrite. Okay, solution. We have to rewrite. Rewrite sine of 5x over x is the same as 5 over 5 times sine of 5x over x. So which is the same as 5 times sine of 5x over 5x. So limit of 5 times sine of 5x over 5x as x approaches to 0 is equal to 5 times 1, which gives us 5, because limit of sine 5x over 5x is 1 from this definition. Okay? Exercise 2. Find limit of tan of 3x over x as x goes to 0. Find your limit, okay? And write your answers in the comment section. Number 7, absolute value. Wow. Okay, first let's start with the definition of absolute value. Absolute value of x, right? Absolute value of x is the same as x if x is greater than or equal to 0, or negative x when x is less than 0. When a limit involves absolute value near the point where the sign changes, compute the left hand and the right hand limits separately. We have to find separately, okay? Now let me show you examples. How do we find the limit which has a 0? 1. Let's start with limit of evaluate limit of absolute value of x over x as x approaches to 0. Okay. Again, using direct substitution, we have what? Absolute value of 0 over 0. This gives us 0 over 0. So let's use the definition, okay? Okay, so solution. For x approach to 0 plus means when x is greater than 0, right? This means when x is greater than 0. Then we have absolute value of x becomes x. So what do we have? So the absolute value of x over x becomes x over x, which is equal to 1. What about for the left side? For x approach to 0 minus means when x is less than 0. So absolute value of x becomes negative x. Okay. So we have absolute value of x over x is negative x over x, which gives us negative 1. This means limit of absolute value of x over x as x approaches to 0 minus is limit of minus 1 as x approaches to 0 minus gives us negative 1. And then limit of absolute value of x over x as x goes to 0 plus, which is limit of 1 as x goes to 0 plus, which is 1. So the two side limits are different. So limit of absolute value of x over x as x approaches to 0 does not exist. Does not exist because of what? Limit of absolute value of x over x as x approaches to 0 minus is different from limit of absolute value of x over x as x approaches to 0 plus 2. Evaluate, okay? Evaluate limit of absolute value of x minus 2 over x minus 2 as x approaches to 2 equals what value, if it exists, okay? Just write your comment, your answers under the comment. So this is enough for today. Next time I'll show you how to find the limits at infinity and infinity limits, okay? If you have any questions or if you want me to do any topics from Calculus 1, let me know. Don't forget to subscribe and like and share. Thank you so much. Bye-bye for now. Mm-hmm.